The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Building High Availability Services on Cloud. And our guest speaker today is Amod Deshpande. He's a senior manager with Accenture. Amod Deshpande leads Microsoft application development capability in Accenture India. During 18 years career equally focused on product development and system integration, he has spent many years in the US with Microsoft, working on server platform product development. He has played various roles in system integration space and provided technology consultation to enterprise clients. In the past, he has worked as principal architect and collaboration practice lead in Wipro Technologies and in systems programming with IBM. He is a practicing architect with industry-leading certification like TOGAF, ISA and CETA. He has worked extensively in capital markets, telecommunications and supply chain management domains. He has 4 patents published in the areas of high-performance computing and media, parse program guide data, multiple on-demand media vendor integration, automatic generation of parallelizable application units. He is an active member of various technical communities and a speaker in Microsoft forums and user groups. Some of his focus areas currently include digital marketing, user experience design, and cloud computing. So without further delay, I introduce you all to our guest speaker today. Over to you, Amod.
Thanks for the nice introduction and welcome all of you to this session. Let me start with the context for this session. I believe all of you are familiar with the cloud today, and the various areas in which cloud is getting adopted is really overwhelming, right? So some of the services that we see on the cloud, which are proving to be the most valuable services for the enterprises, typically in the domains like retail, B2C, B2B areas. And one of the important things is when you have internet-facing services, you really want those services to be available all the time to the end consumers. And even though we put our services on the cloud, which promises a very high availability, the availability provided by the platform really may not be sufficient for your needs. And that is what we are going to look at in today's session to see what availability means. We're going to look at how do we really measure the availability, what is provided by certain platforms like Microsoft Azure for that matter, which is one of the very popular platforms for developing these kind of services. And then we'll look at what are the architecture considerations that we can build on top of these platforms, which will give us additional availability into our application. So that's basically what we are going to look into. So apart from these things, we'll also talk about how these various patterns which have emerged over the last few years can help us really scale and also maintain the high availability across geographies at an internet scale. So that's what we'll talk about in this session. Let's start with what is the definition of availability, right? Let's get agreement on that. So we all talk about downtime, right? So downtime is typically when your service is not available to the intended end users. And when you say downtime, it is inverse of availability. Whenever there is a downtime, there is no availability, right? So that is how one of the characteristics you would you would really want to keep in mind about availability. Any kind of failure that happens in a hardware or a software part of your application, that can really affect your availability. Also, the third point is the performance, right? Your hardware, software may be functioning well. There is no as such a downtime, right? The service is still functioning, but if the performance is very low, right, in that case you may not be able to really call it as an available system for the end users, right? So that's a third function through which you can actually address the availability part of it. Now, what are the other factors that you would want to keep in mind when you really want to address availability? All of us are familiar with what we call it as non-functional requirements or non-functional aspects of design and architecture. So these are some of the factors like cost, complexity, whether it's a CapEx, which is capital expenditure, or OpEx, operational expenditure, and maintainability, right? So all these factors really affect your availability. So as you ask for more availability, your cost also may increase. Complexity of the system may also increase. Your expenditure may in turn increase. So it will depend on you whether you want to spend it as a capital or operational. And then your maintainability needs to keep this availability in mind. You need to make it sustainable as well. It cannot be just at the launch time, but it needs to sustain the future upgrades and feature upgrades as well. So keeping that in mind, let's see how we can measure this availability. What is the industry accepted definition or the formula, I would say, for calculating availability? The way it is typically calculated in most of the systems is that you would take a calendar month and you will take the number of seconds in that calendar month. You will also either plan for or calculate the number of seconds for which the system is acceptable to be down or it was down in a given month, right? So that's again measured in number of seconds. So the difference of these two, and then when you convert it into percentage, that's when it gives you the availability number. Typically the availability number is like 99 point some percentage, right? So that's how you would see it. So when you say 99.9%, those are the 3 nines, and that is most of your cloud platforms will give you at least 1 9 after the decimal point, that level of availability. Now, if you look at some of the big retailers which have the online e-commerce portals, 99.9 is not really acceptable, right? They need to go into much higher, and we'll see how they can get to it. But before that, let's talk about what are those different causes of unavailability, right? What can bring your system down? One is increasing the workload. So you typically design and build your system for certain workload. Now, if the workload grows beyond what it is designed for, and if your architecture is not scalable, then you start seeing a performance dip, and that in turn causes the unavailability, right? In the definition that we saw earlier, there could be certain hardware, software, network failures. There could be transient conditions for non-availability for a few seconds, right? So that can be another cause of unavailability. The third may be a planned downtime or the planned unavailability. When you are upgrading your systems, when you are rolling out new features, when you are changing your configuration, those are some of the scenarios in which you would see the system non-availability as well, right? So these are the trigger points that we need to keep in mind when we are actually addressing the architectural aspects of an application. Now, as I said, I am taking an example of Microsoft Azure as a cloud platform on which we'll build this high availability services. Now the platform itself gives us a lot of options to increase the availability of our services. So first of all, Microsoft provides the SLAs, or the service level agreement, for the role availability, right? So you're ensured that 99 point something is already there, just because you're deploying your service on a cloud platform, which is Microsoft Azure. Now beyond that, there are a few other things, right? So elasticity of the Azure fabric ensure that you can scale. That means if you tag your applications for scaling, Azure elasticity will take care of the increase in the workload, which we saw that can be one of the factors influencing availability. There are a few other things like storage resilience, right? And we'll talk about that in a bit, where it can give you protection against certain types of failures, right? Then there are certain things built into the network, which is network redundancy, right? Any kind of internal or external factors causing faults, how would that be handled by the platform? So we'll talk about that as well. And then the upgrade domains. When you're upgrading the system or upgrading the service, the certain features of Microsoft Azure help you, address the availability as well. So let's deep dive into some of these aspects, right? So what are fault domains? Fault domains are groups, right, which actually may get affected because of certain downtime at a given point. And if you have, let's say, 2 or more instances of your role, right, or the application units, right, into multiple fault domains, if one fault domain goes down for some reason, right, you can imagine that your application may be up into the other one, right? So that way your availability is increased from, let's say, 99.x to 99.95 or 99.9 to 99.95, which is a big leap, right? If you see from the overall availability point of view for your service. Now similarly, what it needs is you need to have at least 2 such instances or 2 such fault domains per role, so that you can get up to 99.95 availability. So all this is just a configuration in your base cloud provider's platform, right? So that itself will give you that level of availability. Now, how would this fault domain work, right? So if you see, what I am showing here are the 3 fault domains, and you have 9 virtual machines deployed into these 3 fault domains. At any given point in time, let's say if domain 3 defaults, right? If any of these domains defaults, then the 2 virtual machines which are there in fault domain 3, VM6 and VM9, will be automatically available in the other fault domain, which is, let's say, fault domain 2. So that is how the virtual machine distribution across fault domains is addressed. In terms of upgrade domain, it's a little different scenario. So upgrade domains come into picture when you want to upgrade your application on a periodic basis, which is a typical case, right? I mean, you would want to release new features, you would want to address some of the issues or the bugs in your service. You might want to just patch it, you might want to do a big bang release. So in such cases, there will be some downtime irrespective of how minimum it is when you are replacing the binaries, when you are actually changing the configuration, right? So the way it is handled is through what is called as upgrade domains, right? So what you do is there are multiple upgrade domains which can be configured for your application. So for example, in Windows Azure, you can go up to 5 upgrade domains. And when the upgrade happens, it doesn't happen big bang, it happens one by one. So let's say if you have allocated 3 upgrade domains for your application, the first upgrade domain gets upgraded first, So definitely it will have its own downtime, but then the rest of the 2 upgrade domains are still up, right? So your customers are still served. When the upgrade of the first gets over, then it's the upgrade of the second and third would happen in a series. So that is how these upgrades are handled without any impact to the availability. Right? So this is one more additional exercise that you can do on what platform provides. Now, what will you do if you want to go beyond this, right? Maybe 99.95% is also not acceptable to you. You want to go to, let's say, what we call it as, 5 nines or 6 nines, right? Which is a very, very high availability requirement. And in this case, we need to also keep in mind several things like the disaster recovery, the geo level failures, the data center level failures. So there are several things, right? A particular country may really go down because of the network outage. It can happen at a continent level as well. So there are several such considerations which actually needs to be handled when you want to go for 5 or 6 nines in terms of availability. So in that case, what comes to help is constructs like traffic manager and the replica strategy, right? So here you have 2 different regions. You can imagine one as, let's say, APAC, which is Asia Pacific region, and the other one as Europe region. So you deploy your services in such a way that one instance runs on Asia Pacific, one instance runs on Europe data center. And then you have a traffic manager in between which actually can route your requests depending upon the availability at that data center. Now you have multiple ways of configuring this, right? You can have an active configuration, you can have an active-passive configuration. When you have active-active, that means your request may be routed to any of the 2 because both the data centers are running. Now it may not be only 2, right? You can go for 3, 4 or 5 or any number of such regions, Azure regions here. Now if it's active-passive, then you are switched to the passive side only when your active goes down and then the passive becomes active, right? So there are various models in which you can configure this traffic manager to work, right? So there are 3 main configurations that you can keep in mind, and that those are very, very helpful in terms of deciding your strategy to deploy your services and sustain those on the cloud. So the first one is a performance policy for the traffic manager. What it means is you have a geo-distributed service. Let's say if somebody from Asia Pacific, let's say somebody from India or Philippines or Australia is trying to access a particular or your service, right? The URL remains the same irrespective of where it is running, right? So if somebody is trying to access your service, then they will be automatically redirected to the nearest hosting point, right? And let's say if it's Asia, East Asia data center, then all the requests from India, Philippines, Australia, or all the Asian countries, or maybe the non-Asian countries but nearest to the DC, right? All will get redirected to this particular data center. And the same will happen in Europe. Let's say any request from UK will go to the Europe data center, right? So that's how you can set it up. The other way to set it up is round-robin fashion, right? If you have large number of users coming into your service at any given point in time, then you really may not concentrate on the geo-specific mapping of those. What you will do is we'll keep on serving requests in a round-robin fashion. The first request will go to data center 1, the second will go to data center 2, and the third will go to data center 3. No matter where it is coming from across the globe. That's the second model. The third model is the failover model. So typically if you have small number of users coming to your site, then what you'll do is you may not want to really pay for keeping all the data center services up. You'll keep one up. If that goes down, then you'll switch to the other one, right? That way it's a most cost-effective solution. And then if the user base is small, that makes a lot of sense. So these are the decisions that we typically make to ensure the availability, at the same time the performance as well. Now, we talked about 3 ways in which we actually see the availability getting affected. Let's look at some of the things which don't directly affect availability in such a way that it brings the entire service down for a long time, but it becomes a temporary unavailable condition, right? So what happens is, if your network fails momentarily, or your SQL is not accessible for a few seconds, so in that case, rather than calling it as a total failure, you need to build the retry into your services, right? Retry logic into your services. You need to know after how many seconds you should typically retry, so that you don't crash as well, right? You need to know what things really help when it's a retry. When to retry, what to retry. It's very important, right? If you're accessing external services, the retry makes a lot of sense, because somebody there also is monitoring the availability of the services, and if something has gone wrong, they may fix it quickly, right? So those are some of the considerations for the transient conditions. Now, irrespective of all these, certain things may fail, right? And those are the real errors or the exceptions that happen into your application. When those happen, you need to have a very robust way of handling the exceptions, and you can't escape from that. In spite of having so many configurable architectural considerations, the code handling the exceptions is very, very important. But beyond that as well, there are certain things which have emerged, I wouldn't say recently, but the adoption is increasing fairly recently, and those are the considerations around DevOps and the self-recovery, right? Where you don't really have to wait for somebody who is the end user to shout that I'm not able to access your service, but you intelligently figure out the unavailability upfront, or the possible unavailability upfront, based on certain patterns, right? And that is what the DevOps and self-recovery really brings to you. Now, just a quick view on DevOps, right? What DevOps is all about how you can integrate the developer and operations mentality together to have the best of the experience from a given service, right? So that is all about DevOps, in my opinion, right? The rest of the things are basically, the process part of it. But the theme behind it is no boundaries. Just make sure that your service is available to the maximum possible time, to the maximum possible number of users. What helps in DevOps is instrumentation. When I say instrumentation, it's basically continuously churning out the information about the health of the service. It's like putting service into ICU in the medical term, right? And having all the parameters checked all the time, so that if there is anything that goes wrong, you get the right alerts at the right time, so that you can quickly react and then fix it upfront before it really becomes a downtime affecting your availability, right? So how do you achieve that? You achieve that through telemetry, right? You automate most of the things. You are logging your error handling has to be extremely precise, right? And there are several telemetry frameworks which have come out across platforms which help you do that. There are some runtime interceptors which actually can give you a very good diagnostic as well, right? And these are the tools which are actually used to monitor the health of this service and provide you the diagnostic data. Now, one of the challenges with all these tools and the telemetry frameworks is that they churn huge amount of data, right? So, it's so much of a data that it's humanly impossible to consume, interpret, understand the pattern, figure out if this is going to affect my service availability, and then take action. So it's a huge amount of data. So you need some way of analyzing that quickly and also triggering action. And the way to do that is automation. So automation is not only in the development part, but automation typically into the operations part, the monitoring part, to an extent that it becomes to some extent the self-service. Right? So that's true even in case of upgrades, right? So when you are upgrading the features of your service, you really are not sure how it's going to be the adoption of the feature. So that's basically the user-centric view. The other view is when you upgrade, let's say if something goes wrong, right? You have done integration testing, you have done everything. At the same time, it may start affecting something technically or maybe from the end consumer point of view. You might want to roll that back. You might want to do a beta release or the test where you want to only target it for certain set of customers, get their feedback, and if the feedback is good, then only you roll out to the masses, right? So those are the kind of things that you would want to do. All this is handled under DevOps scenario, and particularly through the specific architecture considerations for DevOps. Now, when I talk about some of the architectural considerations for upgrades, right? At the same time, the reactions to the patterns which are recognized through the operations, things like Azure machine language really help a lot. So Azure machine language actually can read this huge chunk of data, right? And the data is so much, as I said, right? It could be exceptions, it could be detailed logs, it could be the performance counters that your application is throwing, and then it can relate to the patterns. So, for example, when all this data comes through a monitor and your application's operational diagnostics is running, it can figure out, okay, when your CPU reaches a certain level, let's say 75%, when your memory reaches 80% of utilization, right? Those could be certain hardware indicators is what I'm referring to. And if some of the resources are consumed to this level, historically, we have seen a failure. What I mean is, let's say if in last 6 months you have seen that you have seen, let's say, 4 failures, four times a downtime. Every time there is a downtime, you would see what actually caused the downtime, right? So the cause of the downtime is related to some of the patterns, and these were the patterns. So your CPU was hitting this much, your memory was hitting this much, and all that, right? So that could be one of the considerations. Now, addressing that consideration is a machine learning that goes into Azure ML, right? And then Azure ML churns out a pattern or a workflow saying that, okay, these set of events is causing this failure. Similarly, in your software also, your application also, there could be a pattern saying that if the user is moving from, let's say, wish list to a shopping cart, and if the 3 purchases happen in a single session, it is leading to the failure, right? So that could be application level pattern that you would see that can cause a failure. So those are the 2 patterns, right? All these patterns need a lot of analysis. All these patterns need a lot of data crunching, and that is what your telemetry framework would help you doing with the help of Azure ML. Azure ML is a very good tool for actually identifying and also reacting to patterns, understanding the workflows which actually cause these patterns. One more type of situation would be typically, let's say, if there is a failure, a ticket gets logged, right? And then the ticket is assigned to somebody who does the initial analysis, and then in terms of support, it gets assigned to a support person, right? Who may be just trying to figure out whether this needs a configuration change or it needs a code change, right? So when that analysis is done, you lose a lot of time in that, right? So by the time you figure all that out and then assign ticket to somebody and gets resolved, a lot of downtime may happen, which actually can impact your availability to a large extent, and you may not really be able to wait that much in certain cases, and that's why we are talking about 5 nines level of availability, right, or 6 nines level of availability. That's very, very difficult to sustain. So the way telemetry helps is when the pattern occurs, indicating that there is a potential failure. Maybe I can quickly switch back to this slide so that I can explain it better. So then it actually tells you back in terms of what module of your application or what code segment is where this issue is, right? And that is what this instrumentation is all about. So it is not that you have to just assign a bug to a developer and then go home and the developer comes next day and tries to fix it, because the downtime itself is causing revenue loss of millions of dollars to you, right? So all we are talking about is, if I have to give you a realistic example of this, online retailers, again I'm taking the same example because most of us can relate to that, right? Where you are buying things online and then they ship it to you. Even 1 hour of downtime means a lot to them, right? So, and then they have to keep pace with their competition, right? So they have to upgrade features, they have to release newer applications, newer services, new UI, better UI and all that on a weekly basis, right? So they can't really wait for months to release the new features. So when that is happening, when you are releasing something on a weekly basis, when you are upgrading something on a weekly basis, and then when your consumers are logging into your portal 24/7, right? In the middle of the night, somebody is logging in from some other country, trying to buy something. Even 1 minute of downtime is not acceptable. So we are talking about those scenarios, right? Those are addressed to this telemetry framework. So what happens is going back to the same example, if certain patterns emerge that, okay, this has started happening, it triggers an alert through, let's say, Azure ML-based intelligence system back to the operations, saying that, okay, there's a possibility of downtime if this continues beyond, let's say, next 30 minutes. And then what is the typical resolution to this problem that we actually did last time? So all that information comes to a person who is all ready with all the tools and techniques to fix it, right? It's pinpointed, developers, operations guys, testing guys, everybody is there to fix it, right? And then they know what to do and what action to take. So for example, they may have to actually leverage the elasticity of the cloud to scale quickly. Okay, this is the pattern, add 2 more roles quickly, add 1 more fault domain, increase the upgrade domains, stop the upgrades. These are the actions that they will have to take, and then wait for the low demand period to really go for the upgrades. If there is an outage in the data center, and then that's why the load is increasing, if you are working in active passive mode, then you might want to just switch to the round robin mode quickly. So all these things, all these decisions need to be real-time decisions, and that is what this entire framework enables you to do. Right. Now, when we talk about the data security, that is also very, very important, right? So a lot of data goes into cloud. A lot of data actually is needed when you are upgrading from the data model related changes, when you are upgrading from the previous feature set to a new feature set, right? So all those things typically are handed to your deployment framework as well. So how you are deploying these things to the cloud, right? So the way you do that is you do a alpha release, you do a on-premise release, then you will do a beta release, which is a cloud release but in the beta environment. So every time you are doing these releases, you are doing a level of testing that feeds back into your DevOps framework. Similarly, finally you will deploy it to the production, which is across regions, across geographies, and that's what you will be doing as a final deployment. Every time your traffic manager that I explained earlier comes into picture to route your requests. It acts like your network load balancer in the on-premise data center condition. Some of you may have worked into that, right? So it works into very similar to that actually, but it works across continents, across data centers. So that's how you can imagine it. Okay, I talk about one of the very interesting patterns, which is called as runtime reconfiguration pattern, and this is a very typical scenario for any service which is deployed into the cloud. So a scenario here is not all configurations are done at a platform level, right? Your application also needs a lot of configuration, and that configuration is the key for making sure that it is tailored for a particular locale, language, or a geography combination, right? And then typically things like currency and all those areas. It is also connecting to the third-party systems, whether it's a payment gateway, whether it is some other B2B service that you are connecting to, and all these things are typically kept into a configuration. That could be a configuration file or some other configuration database from which your application reads. Excuse me. So this runtime reconfiguration pattern is very useful in such scenarios to avoid any downtime or any impact to the availability of the service. Now, how it does is you have a configuration stored in one point, and then you have your service running on a given virtual machine or in the platform, right? So the configuration updates, when those happen, those are asynchronously read and fed into the memory footprint of the service, and that is what this pattern is very useful for, right? So your service need not be physically restarted when you are actually applying the new configuration, and that is the beauty of it. Now you might want to revert the changes. That also can be possible through such configuration. You can cancel that, and in worst case, if you have to restart the application, then you know that we have the other ways of handling it, like upgrade domains and things, so that you can still do the restart. But the runtime reconfiguration avoids the service restart and the application. So these are 4 or 5 important patterns that we just saw, which actually can help you manage all these services on the cloud and the highest availability. And so in summary, right, if you are really looking for very high availability of your services, first is your bet is on the platform. So you have to choose the right platform which gives you a lot of availability related features. You have to choose the right architecture and the architecture patterns which will help you address some of the failures, downtimes, external dependency related failures, transient challenges, right? And then you have to also have a right instrumentation in place, like a telemetry framework and the DevOps configuration on top of it, which can automate the entire life cycle, which gives you a comprehensive control and monitoring as well as deployment control, so that you can ensure the highest availability of your systems. And with this combination, with the example that I took on Windows Azure, you can reach up to a very high availability of 6 nines. So, before I go to questions, I see a lot of questions here. A few takeaways for you. When you start on the high availability exercise for the services to be deployed on cloud, you need to really measure those, right? So the way we saw the formula for calculating availability, you need to have a very clear understanding of the requirements. It cannot be vague that you need a very high availability for this service. It has to be calculated mathematically a figure that you need to target, right? So that you know what all measures you would need, and then you can decide on the trade-offs, right? Because 1/9 additional may mean replication across 2 data centers, which means a lot of money. So all those things you have to consider. Secondly, you need to analyze the various features of the platform, whether Azure or any other cloud platform that you select. You need to understand the features in depth. What is possible, what is not possible. DevOps is a definite thing that you must go for, right? You cannot live without DevOps and ask for a very high availability of your cloud services. You need to monitor each and every activity that is happening in your service as well as in the environment. Early feedback, automated feedback, pattern recognition, and quick recovery. These are very, very important things. And finally, apply all known high availability cloud patterns. So I think this is what I would say is key to high availability services on the cloud. So let me start with some of the questions, and I would definitely like to answer all the questions which are getting posted here. Keep posting more as well as we talk on this. So there's one question from Anshul Kumar. It says, what do we mean by fault domains? I believe I explained at a later point after this question was asked, but if I do switch back very quickly to that slide, the fault domains is basically a logical and physical grouping of, let's say, your units, whether it's a role or a virtual machine, right? And these fault domains are the unit of failures. So for example, if there is a platform upgrade that's going to happen in Windows Azure, at that time this one particular unit goes down, the upgrades or the maintenance activities carried forward, and then this entire unit comes back up, right? So this is a basic unit of maintenance for a given cloud provider. That is what you can imagine as a fault domain. I hope that answered the question. So let me move on to the next question, which is from Vikram Karmarkar. How do you handle network latency if users in APAC access the application hosted from Europe? So this is a very good question and very interesting one as well. So let's say if you have hosted your application in only one data center, which is Europe, and somebody from Asia Pacific is accessing that. So we talked about multiple ways of configuring your traffic manager, right? Now, if you have configured it for performance, right? In that case, what happens is, you would not run into this scenario, right? Your traffic manager would take care of routing it to the APAC data center. But if you haven't configured it performance, if you have configured it either in a round robin or in a failover mode, in that case, obviously the network latency would come into picture, and that's your call as a business lead to take, whether how many of my users are coming in from what region, and you need to choose your data center carefully to make a decision on where you should be deploying the service and whether you should be deploying in active mode across 2 data centers. So that is the business. It's a cost versus availability or latency factor that you would want to take into picture. It depends on the business model, it depends on your investment that you want to make, and it depends on your user base as well. If you're anticipating majority of your users are coming from Asia Pacific, you would not want to put your service on Europe data center. You would obviously put it on the Asia Pacific data center. Okay, let me move on to the next question. It is from KU Thakkar. Do we have to manually set model policy for traffic manager, or it is determined automatically? So yes, the traffic manager configuration is with us. We can set that, but when you set it, let's say for round robin, right, or failover, then it is triggered automatically internally. Once you say that it's round robin, you don't have to, for every request or set of services, you don't have to tell that now go to this data center or that data center. Once it's defined, it's all handled by traffic manager internally. Okay, again there is a question from Vikram, says, is traffic manager a black box network device or an application hosted on a server? Any examples of traffic manager? Okay, so you can consider traffic manager as a configurable box, right? So it allows an interface through which you can deploy policies to that box or a server, and then internally the functioning of the traffic manager is abstracted, how it does it. But you can go to the extent of defining which data centers, what policies, all that is part of the configuration of the traffic manager. So I would say it's not completely a black box. At the same time, it gives you control only through the predefined interface, right? So it is part of the Azure platform, right? So and then it is well integrated with the Azure Fabric, and it can connect to any data center in the world, right, that Microsoft has today. So given that the traffic manager is accessible to everyone from every data center, that's the accessibility part of it, right? And it's a single entity, so it's not like you'll have multiple traffic managers that you would typically go through. It's going to be a single traffic manager talking to your service at any given point in time. So that's how it's implemented. Okay. We have a few more questions as well here. One question is from Abhijit Chakravarti. If I'm using Azure Infrastructure as a Service, how do you suggest zero downtime upgrade to be handled? Okay, so whatever patterns or whatever configurations, platform configurations that we saw, many of those apply to Azure Infrastructure as a Service as well, right? So in fact, the example that I gave on the fault domain, it is applicable to virtual machines, in fact, right? So there is nothing like zero downtime, right? We never say that we can achieve 100% availability. We can say we can keep adding nines probably, right? And typically I haven't seen anything beyond 6 nines. That whether you go for a cloud, public cloud, or you go for private cloud, or on-premise implementations, any other implementations, beyond 6 nines is something which is not seen. So there is always a chance of failure no matter what you do. But then how do you minimize that? How do you ensure the highest availability is what the question is. Okay, one question from Vaibhav Shah. Vaibhav wanted to basically note down the formula for calculating the availability. Let me quickly switch to that so that we can do that. So if I have to go over this formula again, X is the availability, and the way you calculate that is N minus Y into 100 by N. N is your total number of seconds in a calendar month. So obviously a calendar month could be 31 days or 30 days or 28 or 29 days depending upon which month you are talking about. So typically we calculate availability on a month basis. Cloud providers like Microsoft or any other providers as well, they would specify the availability for a given month, right? Which is in terms of SLAs also, it's easy to manage, understandable, and measurable, right? So that's why we're taking an example of a month. So in a given calendar month, if these are the total number of seconds, right? Total. That means it's not like working hours or whatever. It's basically total number of seconds, and then the total numbers when the system was or can remain unavailable, right? That is subtracted from that, and then you multiply by 100 by N so that you can get a percentage of it. Hope that helped. Let me move on to the next one. Okay, very interesting question from Krishna Kishore. What is the role of production support in DevOps model? So DevOps, there are several definitions of DevOps, and we can actually see very detailed information about DevOps on internet, and various different vendors are promoting DevOps today. So the role doesn't change, right? So what DevOps does is it basically breaks the boundaries between developers and production. Now, going back to the way development and production happens, if I were to give you an example, right? A developer says that, okay, it is working on my machine, my job is done, I'm going home, right? And the developer can always prove that, okay, it is working on my machine. So what's wrong? When it is deployed in production, the production guy says that it's not working in the production environment. This is not done. So production guy says, unless you give me a working version, I can't deploy it here. And the guy goes home. Now the business is suffering here, right? The business says that, okay, I don't care whether it's a developer's problem or an operations problem, but solve the problem. I can't just say that you can't just keep finger pointing at each other. So DevOps basically brings developers and operations guys equally responsible, and in fact in some organizations even the role is played by a single person, right? I mean, that's not the ideal situation to be in, but it requires so much of agility. As I said, right, you can't afford 1 minute of downtime, otherwise you lose thousands of dollars of revenue. When you are in such a situation, you can't say that, okay, it's working on my machine, I don't know why it's not working on that machine, right? So it's basically plumbing the two together, which is DevOps. And talking beyond roles, the operation support people need to understand how the development happens. They need to understand what are different modules in the code, and when the fault occurs, when they get an alert, they should be familiar with the code to such an extent that they should be able to say that, okay, there is a failure in authentication module, right? And then the respective developer jumps at it. So it has to be very, very tightly integrated scenario between developers and operations. Okay. Are there fault domains in other cloud platforms? One of the questions from Hemant Gaidar. So yes, I mean, there are similar constructs like fault domains are explained on Windows Azure in other platforms as well. The nomenclature is different. The configuration parameters may be different, but yes, I mean, the cloud providers would typically look for providing such kind of construct for sure. And that is one of the advantages of getting onto the public cloud, actually. Okay, let me see some more questions. Okay, so here's one more question from Jatin Kindra. The question is, which service vendor is preferable for B2C platform with web and mobile load out of various different platform providers in terms of cost, performance for an initial age organization? Okay, it's a very good question actually, and this is a question majority of our customers ask us in terms of which platform you would recommend us to go on. And there is no easy answer to this. There is, but there is not. So the way I'll explain this is we actually have built a tool which actually it's a questionnaire around 20-25 questions with certain inputs which are required from the end users who are looking to go onto the cloud, which does the analysis and then recommends you which cloud may be helpful for you. So it's not like one is better than the other, but it depends on what are your requirements. There are several tools in the market as well which actually based on the end user inputs can recommend you a particular cloud. If you see from performance point of view, all these platforms have been evolving and adding a lot of new features. And it depends on whether you're looking for platform as a service, infrastructure as a service, software as a service, the integration with other existing services. Now, there are several factors that needs to be considered. So I wouldn't be able to call out one particular vendor just based on one question here. Obviously open to have an offline conversation to analyze it more. Okay, there's a next question from Brijesh Singh. The question is, what is the difference between fault domain and upgrade domain? Okay, so fault domains are typically related to the maintenance or the data center level failures, right? So something which may be planned or unplanned. While upgrade domains are typically for the planned upgrade of the system. So when I say planned or unplanned maintenance related fault domains is, let's say, some of the switches in the data center need to be replaced, or they are tripping very frequently. The hardware vendor has called back those switches and all that, right? If that needs to be done, the rack needs to be switched off, right? It has to be switched off because otherwise you can't change the switch, and it needs to be switched off maybe for 1 hour. When you are doing that, the way fault domains are structured, that if you have distributed your application across 2 fault domains, those 2 fault domains cannot go down at the same time, right? At a given point in time, only 1 fault domain will go down, so that the other fault domain will still remain available for you. So that is how it is. Now the upgrade domains are not related to the hardware, software failures or maintenance related activities. Upgrade domains are related specifically to your service or your application, right? So when you are putting the new binaries in, when you are upgrading your service, at that time that binary replacement, configuration replacement may take some time. It may be 5 minutes, it may be 10 minutes, but at least that much is your downtime. To avoid that, you actually have multiple upgrade domains where your application is hosted, and it happens only in a planned fashion, right? So that's the difference between the two. Okay, I see not many questions. I just have a few more minutes left. Let me see how many of those I can quickly answer. Okay, so one more question is, every service needs different traffic manager or one manager? Okay, so the question is mainly basically you need multiple traffic managers or single traffic manager. This is from Rajiv Mukhopadhyay. So the answer is, as I said, the traffic manager is part of the platform, right? And you interact only with one traffic manager to your service. So you don't need to really build a traffic manager or create new traffic manager. It's part of the system, it's part of the platform. You just deploy policies related to your service into the into that particular traffic manager that you are configuring or accessing. Okay, last question here that I can take today is from Anil Verma. The question is, who should configure and monitor the telemetry? So telemetry, the entire framework needs a good collaboration between developers and operations. Who should build it? It should be the developers, or there are third-party applications which are available which provide a lot of telemetry features that needs to be there. The configuration has to be a joint configuration, and that's why the role of the DevOps is very, very important here. So it's a DevOps collaborative effort to configure that and monitor that. With that, I think I could answer most of your questions, and thank you for patiently listening and attending and making this very much interactive.
Thank you so much, Amod. I'm really thankful to our guest speaker, Amod Deshpande, for conducting this insightful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgig.com very soon. Thank you everyone, and have a wonderful evening ahead.